Welcome to a new video which is about graphing trigonometric functions. In this video I'll give you a general tip that you can apply to draw the graph of trigonometric functions. Without further ado, let's get started. I put here four major trigonometric functions which are sine, cosine, tangent and cotangent. I also put here some values of those functions, like for example at the point 0 radian or 0 degree, at the point 90 degree or 180 degree, 270 degree and 360 degree, or their corresponding radian values. So it's better to know those values, guys, in order to draw the graph of trigonometric functions. For example, for sine of x, sine 0 is 0, right? Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi divided by 2 is -1. And sine 2 pi, which is 360 degree, is 0. So if you look at these values, guys, from 0 to 1, there is an increasing. You can think it in this way. From 1 to 0, the value is decreasing. From 0 to -1, still our function is decreasing. From -1 to 0, the graph is increasing. We can think the same thing for cosine of x, guys. Again, we need to know this order for the values of x. For cosine 0, it is 1 also. For cosine pi over 2, it is 0. Cosine pi is -1. Cosine 3 pi divided by 2 is 0. Cosine 2 pi is 1, guys. And again, if you compare those values from 1 to 0, there is a decreasing, right? From 0 to -1, still the graph should be decreasing. From -1 to 0, there is an increasing. And from 0 to 1, there is an increasing also. And now I put here the graph of two functions. This is the graph of sine of x, which I already put it here. And this is the graph of cosine of x, guys. For sine of x, as you can see, the 0 point is right here, right? For pi over 2, okay, which is the top highest point for sine of x, and the graph shows 1, right? So we are here. For pi, again, the value of the graph is 0. So the graph should pass through from this point. For 3 pi divided by 2, the value of sine is -1. For 2 pi also, we have 0. So again, if you look at here, from 0 to 1, there is an increasing, right? So it's increasing in this way. From 1 to 0, as you can see right here, it's decreasing slightly, right? And from 0 to -1 right here, right, it's again decreasing. From -1 to 1, it's increasing. You can memorize the graph of sine of x in this way. When it comes to cosine, again, cosine 0 is 1, right, which I already put it here. So we start from here. And then cosine pi over 2 is 0. So just combine those points. For cosine pi, we have -1. So still, as you can see, the function is decreasing. For cosine 3 pi divided by 2, which is 270, right? And it's increasing because it's coming from -1 to 0. And from 0 to 1, again, it's increasing. So it is very important to know those values, guys, if you want to draw the graph of the trigonometric functions perfectly. When it comes to the graph of tangent x, guys, as you can see, this is our graph here. And if you look at the values at the point -pi over 2, which is right here, the function is coming from -infinity, actually. It's not touching -infinity, but if you look at the limit goes to -infinity. Anyway, think that it's coming from -infinity. At the point -pi divided by 4, the value shows 1. So actually on graph of tangent x, this point is -1, guys. So this point corresponds to -1. At the point 0, the function shows 0. Why? Because it's passing already from the origin. And at the point pi over 4, as you can see, this is pi over 4, right? And there is 1, right? Because its corresponding value is 1. And at the point pi over 2, again, the graph goes to +infinity. Again, it doesn't touch the infinity, but the limit is infinity. Because the period of tangent x is pi, so for every pi value, the function repeats itself. As you can see, it's coming, passing from 0, and it's going to pass infinity. It's coming from -infinity, it's passing from origin, which is 0 actually, and it's going to +infinity. So for every pi value, the function repeats itself. And when it comes to graph of cotangent x, at the point 0, the function comes from infinity. If you look at here, this is the 0 point, right? It's coming from the +infinity. Again, it doesn't touch the 0 point. the limit is infinity. So it's coming from the infinity, if you can think it in this way. And when it comes to the value of pi over 4 for cotangent x, we have 1. Actually, this point is like pi over 4, okay, and the value corresponds to 1 here. And at the point pi over 2 for cotangent x, we have 0. And at the point 3 pi divided by 4, we have negative 1. So actually, this is negative 1, guys. And that point is 3 pi over 4. And for the value of pi, again, we have negative infinity. The function goes to negative infinity. And again, here, guys, for cotangent x, because the period is pi, so for every pi value, the function repeats itself. And again, here we have the same thing. Here also we have the same thing on the left side. If you consider the tip, how we can draw the graph of the trigonometric functions, well, it's better to know the graph of sine, cosine, tangent, and cotangent, the graphs that I will show you here. And in order to draw those, or in order to keep them in your mind clearly, of course, we should know those values, guys. We should know this table, actually. And in order to draw also the graph of the functions, we benefit the amplitude if it exists, because for tangent and cotangent, it doesn't exist. Or at least if you know the periods, okay, if you can find out the period of the functions, then that is going to give you a lot of information to draw the graph of the function. And this is our first example, guys, in this video. And it says, plot the graph of y is equal to f of x, and that is also equal to cosine 3x. I will put the graph of cosine 3x here, but how you would plot this graph, guys? Well, first of all, it's better to find out the period of cosine 3x. If you remember, the coefficient of x here is 3, so the period is 2 pi or 360 degree divided by the absolute value of 3, right? So from here, guys, we have 360 divided by 3, which is 120, guys. So for every 120 degree, the graph should repeat itself. Actually, if you look at here, this is 120 actually, right? So how we can plot the graph of cosine 3x? If you put 0 instead of x, let me make a table here for x. So when x 0, guys, cosine 3x is cosine 0, and cosine 0 is 1. So I'm going to put here cosine 3x. When x 0, cosine 3x is cosine 0, right? Cosine 0 is 1. So it should pass, or it should start from here, this point. When x is 30, cosine 3x is 90. Cosine 90 is 0, guys, right? So this point is 30 degree, but it corresponds to cosine 90 degree, guys, okay? Because if you put 30 here, then we're going to have cosine 90, right? If you put 60 instead of x, which is right here actually, 60. And then we have cosine 180. Cosine 180 is negative 1, guys. And as you can see, it corresponds to negative 1 here. And when x is 90 degree, 90 times 3 is going to be 270. So cosine 270 is going to be 0, guys, again. So we have 0 here. And as you can see, it passes from the point 0. And when x is 120 degree, then 3 times 120 is 360 degree. So cosine 360 is plus 1, guys. And as you can see, this is x is equal to 120 or cosine 360. So as you can see, because the period is 120, right? So for every 120 degree, the function starts repeating itself. It goes in a similar pattern, okay? And it goes to infinity. And this is how we can plot the graph of cosine 3x. And of course, you need to combine those points, right? If you combine those points, then you can easily plot the graph of cosine 3x. And this is our next question, guys. And in the next question, it says plot the graph of y is equal to f of x, and that is 1 divided by 2 times sine of x. Well, I already put here the values, guys. When x 0, when x is pi over 2, when x is pi, 3 pi over 2, and 2 pi. For those values, sine of x is 0 at the point 0, right? Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is negative 1. And sine 2 pi is 0. So if you multiply those values by 1 divided by 2, right? Because our function is multiplied by 1 divided by 2. So 1 becomes 1 divided by 2. Negative 1 becomes negative 1 divided by 2. If you compare those values from 1 to 1 divided by 2, the function is increasing, guys. So just put those values on the coordinate system, right? This is 90 degree, which is pi divided by 2. 180, which is pi, 270, which is 3 pi over 2, and 360, which is 2 pi, guys. So from 0, the sign is 0, right? So the function should start from here. And when it comes to pi over 2, the value is 1 divided by 2. So the function is increasing, guys. As you can see, it's increasing in this way. It's a little bit curved, right? It's not straight, but it's a curve. So 1 divided by 2, or half, is at the top. And from 1 divided by 2 to 0, the function is decreasing. With a little curve, it's decreasing. And from 0 to negative 1 divided by 2, still it's decreasing, right? This is negative 1 divided by 2, which is negative 0.5. With curve, it's decreasing. And from negative 1 divided by 2 to 0, it's increasing, guys. And you can plot the graph in this way. And this is our last question, guys, in this video. In the last question, I put a little challenging questions. It says plot the graph of y is equal to f of x, and that is equal to, guys, 3 sine x plus 1. Actually, this question is about also shifting, but how we can plot a graph of such a function. I'll show you how to draw such functions, guys. As I put here, I recommend you to make such a table first, guys. So because we have sine x here, right? So I put here sine x, and then our function is multiplied by 3, right? So we have 3 sine x here. And then finally, we are adding 1 to the value of 3 sine x. As a last term, I put here 3 sine x plus 1. So for every value, for example, 0, 90 degree, 180, 270, and 360, let's find out the value of those. By up to 2 pi, I put here the values, because the period of sine x is 360 divided by the absolute value of 1, which is the coefficient of x here. So we have here, guys, 360. That means the period of 3 sine x plus 1 is 360, and that is why I put here the values up to 360 or 2 pi. So if x is 0, sine x is 0, of course. If x is pi over 2, then sine x is 1. When x is pi, we have 0. When x is 3 pi over 2, sine x is negative 1. And when x is 2 pi, sine x is 0, guys. If sine x has those values, then 3 sine x means we're going to multiply each value by 3, right? So 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. Finally, I'm going to add 1 to each and every one of these values. 0 becomes 1. If you add 1 to 3, it's going to be 4. If you add 1 to 0, we are going to have 1. If you add 1 to negative 3, we're going to have negative 2. And if you add 1 to 0, I'm going to have 1 here. So finally, these are the values that our function should show, guys. So let me draw the coordinate system first. Suppose that this is our coordinate system, guys. When x is 0, 3 sine x plus 1 is 1, guys. So we're going to start from here, which is 1, right? Let me change the color. So when x is 0, we're going to have 1 here. So we're going to start from here, guys. When x is pi over 2, we have 4. So our function should pass through from here. When x is pi, we have 1 here. So pi means 180, right? So it should pass from here. And when x is 3 pi, or let's say 270, then we're going to have negative 2, guys. Let's say this is negative 2. This point should be at this point. Our function should pass through this point. And at the point 360 or 2 pi, we have 1 here. So we're going to come to this point, guys. This is 1 here. So here from 1 to 4, it's increasing in this way. From 4 to 1, it's decreasing. Suppose that it's a curve. And from 1 to negative 2, it's decreasing. Suppose that it's decreasing in this way. And from negative 2 to plus 1, it's increasing, guys. As you can see, function of 3 sine x is shifted by 1 up to 1, actually. It was like this. This is the function of 3 sine x. If you add 1 here, guys, actually you are shifting the function by 1 towards the upside. Every value is moving towards the upside. That means negative 3 becomes negative 2, right? And this starting point, which is 0, becomes 1 here, because it's shifted by 1 towards upside on the y direction. And that 3 becomes 4, guys. So by adding 1 here, actually we are shifting the value by 1 on the y direction by 1 unit. So in such questions, guys, first of all, I recommend you to make such a table, step by step, write down each function like I did here, sin x, and then 3 sin x, and then 3 sin x plus 1. And for every one of those functions, write down the corresponding values, and then finally, whatever you have here as a final step, okay, draw this function considering the degree values here or radian values. I know that it's not an easy topic. You need to make more practices on this topic. And if you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.